Okay, we finally made it to angular velocity problems. So I'm going to do 81 first, just going right down the line. We've actually done this one as quiz review, but it's also good for our chapter test problem as well. So if you look at 81, all they're going to give you is the diameter of a wheel and the revolutions per second. So from there, they're asking you to find A, the angular velocity, and B, the linear velocity. So, in general, before we look at 81 specifically, if you're given RPMs, that's revolutions per minute. To get to angular velocity, you need to take revolutions per minute. Angular velocity is going to be radians per, per minute. Angular velocity, radians per minute. So our minutes start at the bottom, they end at the bottom. So we don't do anything with time. To get from revs per minute to radians per minute, we need to cancel out revolutions. So we put it in the bottom. We also have to add radians to the equation, so we put it on top. Okay? So we take revolutions per minute times radians per revolution. Well, we have to put some numbers in there. In this case, how many radians are in one revolution? Well, one revolution is one circle, one time around the circle. And one time around the circle we know to be 2 pi radians per revolution. So if you're looking at any problem given RPMs or even revolutions per second, if you look at 81, they give you 2.5 revolutions per second. It's no different. We're just going to take that times 2 pi, and that's radians per revolution, just like we did up above, and we end up with 5 pi radians per second. That's it. That's part A. From revolutions per time, whether that time is minutes or seconds or hours, angular velocity, you just multiply by 2 pi. Part B, here's where it gets not harder, it's just you got to be careful of what you're multiplying and dividing by. So we start with 5 pi, and our units are radians per second. Now I'm just going to put a bunch of fraction bars. I believe that's enough, so seconds, radians, inches, feet, that should be enough. But in the end, we have to go from radians per second in part A to miles per hour for our linear velocity. So when you go back, you say, okay, we start with seconds. We need to end with hours. Well, we need to cancel seconds, so we're going to put them up above. And we can find out 1 hour is 3,600 seconds. So looking at that, we've canceled out our seconds. Our hours are now in the bottom like they should be. Next up, radians. Well, we have to put radians in the bottom. And what do we put on top? Well, in general, when you go from angular to linear, let me put a little note here. This is times 2 pi. From angular to linear, you just multiply by your, well, let me put that in lowercase. Multiply angular by your radius. Well, that's where we're at in this step. Our radius in inches. If you look at the problem, they give you 15-inch diameter. That gives us 7.5-inch radius. But if you notice, our units, inches per radian. Well, remember, 1 radian is the length of 1 radius. So, radii cancel. We now have inches per hour. Well, we need to cancel inches then. There's 12 of those. And our next unit is feet. We do that multiplication in division. We have feet per hour. And last we have feet in the bottom to cancel. Our next unit would be miles. So 1 mile is 5,280 feet. Our feet cancel out. We have our miles per hour. So in your calculator, take your 5 times pi times 3600 times 7.5, and I would hit enter right then, and then just, if you hit the times key, in parentheses 12 times 5,280. Your answer is about 6.69 miles per hour. That is number 81, our angular velocity problem.